Hello and welcome. In my last video, which was about the Longwei LW1641 function generator, I talked about some of Longwei's other products, and I mentioned that I may or may not have one of these, the Longwei TVT-322 2-channel AC voltmeter. And of course, here we are, and this is going to be today's subject, which I bought in January 2016. It was a bit of a hassle to purchase because I couldn't find one of these on eBay. At least I don't think I could, or if I could, the price was bad. So what I ended up doing was using what's called a Taobao agent. So there's a website called Taobao, which is essentially the Chinese version of eBay, and normally people outside of China don't use it, but there are these things called Taobao agents which will purchase things from it for you and sort of forward them after they're shipped. So that's what I ended up doing with this thing, and it was pretty cheap even after the shipping from China. And of course, the reason I bought it is for use in calibrating reel-to-reel tape recorders. The thing is, no company makes this type of device aside from Longwei at this point, and I didn't really want to deal with a used unit on eBay that tend to sell for quite a lot these days. So I figured the LW1641 is okay, and so I may as well see what Longwei's version of an AC millivoltmeter is like. And these are indeed much better for tape machine calibration than digital meters because, first of all, they can measure frequencies higher than say, one of these accurately. This cannot measure high frequencies accurately. It's spec'd at maximum 400 Hertz, and of course the audio frequency spectrum goes up to around 20 kilohertz. But also, this is much better than a digital meter for measuring signals that change quickly, or that change that are not extremely stable, because instead of looking at a constantly changing number on a screen, you get these nice pointers. And overall, I've been relatively satisfied with it so far. It does have one problem that has developed in a year of not very heavy use that we're going to try to fix today, which is, well, I'll demonstrate in a minute. First of all, let's have a look at what we have here. Okay, so first of all, here's the actual meter. This it's quite nice, quite large, and it has these two pointers here. The black one is for channel 1 and the orange one is for channel 2. And of course, right now what I have going into it, I have this microphone, nice old realistic mic, that's going into a Tascam 32 reel-to-reel, which is just giving a nice mono output, which is being fed into both channels. And if we look here, we have different scales on it, of course. We have the 1 scale and the 3 scale, so for the ranges beginning with 1 and 3 respectively. We also have some dB scales. I like the one there which is green, that's the dBV scale, and then we also have dBm. And we have some notes here. We have class 1.5. I'm not entirely sure what that means. We also have a little sort of logo down there. Also not sure what that means. We have the range adjustment on the front there. Those two plastic screws for zeroing it. I will say one thing, which is, okay, let's pause for a sec. If you can see here, the pointers are not perfectly parallel. If we take off the camera, we can look inside. You can see from this angle that they're kind of skewed from one another. And you know, it's not perfect, but again, it's not the most expensive device, and the actual movement of the meter is quite good. Now, looking back at the front here, I've disconnected the signal for the moment so that we can clearly see the stuff here. So of course we have our range selection, and this is the range selection rotary switch for either channel 1 alone, that is if this button is out, which it is right now, or if you push this button in, this is the range selection for both channel 1 and 2. And then over here, this is the channel 2 range selection for when this button is out. Of course, here's our inputs, channel 1 and channel 2. These are just BNC connectors. And if we go ahead and put the mic back, we'll be able to see what our problem is that we're going to try to repair today. Okay, if you can see here, both pointers are moving pretty much in sync with one another. The channel 1 and channel 2 range selection are both at 1 volt. So if I change this channel 2 selector button, if I push it in so that the knob on the left will be used for both channel 1 and 2, you can see that now channel 2 is quite a bit more sensitive than channel 1. It's deflecting quite a lot more. And so this is the problem. I think what's kind of happening is that it's instead of acting like 1 volt range, the channel 2 is kind of stuck on the 0.3 volt, because if we turn it down here to 0.3 volts, then we have both needles deflecting in a similar fashion. And if we put it up to the 3 volt range, they're also in sync. So it's only the 1 volt range that this is a problem. So now, before we turn it around, I'm just going to turn it off, and you'll notice something happens when you turn it off, even when there's no input. So those needles really slam against the side there, and it's you'd think they could have not had that happen, but so far it hasn't hurt anything. And if you turn it on, you see they deflect somewhat, but they don't slam up here. They just kind of go up here briefly, and then they will settle, as you can see. They're not quite at 0 yet, but they're slowly coming towards 0, and eventually they'll end up there. So something, you know, it would suggest that the design is not perfect. So now we're going to go ahead and turn it around. First of all, actually, let's see, the sides are alright. I mean, it's kind of like the LW1641 in that we have kind of a plastic bezel thing here, and then plastic knobs. Although, unlike the LW1641, this is a metal front plate kind of thing with the lettering on it. The case is metal. See, and we have this nice carrying handle on it, and of course rubber feet. Nice rubber feet. And then on the back, it's pretty darn simple. We have the outputs for each of the channels, which I don't think they're direct. I don't think they're direct connections to the front. They might have an amplifier stage between them, but I'm not entirely sure. I don't really use them. The ground mode, which you can change between open and ground, which could be useful. Of course, it does use an IEC plug here. This is a standard IEC, but guess what? You might notice something here. 220 volts. So unlike the LW1641, this does not have a dual voltage capability. So we have only 220 volt AC power, and this is kind of annoying. What I had to do about this is to use this guy. This is yet another piece of wonderful Chinese stuff. This is a step-up transformer, although, I mean, you can step up or down, but in this case I'm stepping it up to about 240 volts. And this is okay because, you know, the power supplies inside are regulated, and they can handle the slightly higher voltage on the secondary of the power transformer. And it's within the spec of the manual, as we'll see. But basically this is being used to step up the voltage, because otherwise we wouldn't be able to use it here in Canada, where the line voltage is 120 volts. Looking at this as well, we have a similar Chinese description sticker as on the LW1641. They still have the wrong website address. It's classic CE. This one looks pretty good. It might even be the right proportions and stuff. RoHS compliance, QC passed, serial number, all good. So now we're going to go ahead and open it, and it's pretty simple. I'm not going to do this on camera, but we just have 4 screws, 6 screws. 1, 2, 3, 4, and then 2 more on the other side, and then this guy comes off. Okay, so now we have the thing open, and we can see there's not a whole lot inside. This is the power transformer, which, by the way, had loosened itself quite a bit during shipping. This one of these bolts had the nut had come off, and it was just kind of flopping around, sort of dangling from one of these, and luckily it didn't fully detach, but you know, that was pretty easy to deal with. We can see we have 2 circuit boards, or 2 main circuit boards, I guess you could say, through hole, single-sided. So why don't we zoom in here a bit. Let's get a look at the parts. Okay, so now you can see that better. We have some ICs, which, let's see, CD4066, that's like an analog switch, I think. CD4049, so, you know, pretty common stuff. Not in sockets, unfortunately, but not too bad. It's single-sided, so they wouldn't be that bad to desolder. This is kind of the power supply section, I guess. There's a bridge rectifier. This is presumably a voltage regulator. Big capacitor here. Let's see, what brand is this? Yeah, looks like pretty much all these electrolytics are Jwco, JWCO, with a big J there, so you can see the logo. You can see the logo on that one. A little suspect maybe, but again, those are kind of easy to replace, and I think, as I mentioned before, oftentimes this cheap Chinese stuff, you can pretty much, it may have flaws, but you can make them better if you want. Like, if I wanted, I could replace all these caps with Nichicon or Panasonic or whatever, and they'd probably be more reliable. But so far they've been reliable. I've had no problems. Let's see. Okay, these, you know, film capacitors, whole bunch of little transistors, metal film and carbon film resistors, looks like. If we look at the other board, here's the other board. You can see we have a few little sections that look shielded, like these little shields. And in fact, if you notice, both boards are identical. I guess one for each channel. So you can see, you know, this one, the power supply is way down there, and shielding here instead of down there. If we look at the back of one here, we can see the soldering is pretty good actually, nice shiny, which I don't think says it much about the rose compliance if it's so shiny, but who knows. If we look, there's not really any, well, there's one little bit of questionable area with the resistor across, and then this little trimmer, which is well, I think you could almost say that's sort of surface mount, and it's really, plastic is beat up for some reason, but oh well. We can also see something that we did not see on the other guy, the function generator, which is a little thing here that says designed by Lys, L-Y-S. So that's kind of neat. Somebody taking credit for their work, I guess, although I bet it's quite a bit based on other designs, although I don't know what designs. Let's see, we can see this is the big meter. This is the back of the meter there. This is quite large actually. We can see as well, it doesn't use connectors on the boards so much as the LW1641. You can see this is not in connectors, but it's simple enough that it's not so bad. There are some connectors, like there's a connector down here. This is for that range selection button, and here's the power LED with its leads intact and just soldered onto. And then down here, this is the area with the rotary switches for the range selection. So this is what we're going to be looking at for the repair. And unfortunately, it's pretty jammed in there. But we'll figure it out. Okay, now before we go on to the repair, I'd just like to talk a bit about the manual. I'm not going to do a thing like in the last video where I showed all the things it comes with, because it doesn't actually come with very much. It came with the Chinese IEC cord, which of course has the wrong plug, so that's easy. Just use the right kind for here, and then came with some of basically the exact same alligator clip leads that the LW1641 had, maybe slightly better, but not really. And then of course the manual. So here's the manual, and this time we actually get the model number on the front, and they're calling themselves LWDQGS, which I don't know why, but let's not worry about that. Let's see, I mean, we have operating instructions, specifications, some notes. This is mostly what you might call a user's manual, because it doesn't have any information on maintenance, calibration, no schematic, no block diagrams, unlike the LW1641, which did have some block diagrams. And as you can see, I mean, it's a small enough manual already, but it's actually split here. First part's English, second part is Chinese. And of course the English, well, let's just have a little sample of this here. Select a fuse with same rated capacity as the Bowman one, Toraplas. So, it's English, but it's not completely incomprehensible. If we do look back at this, we can see that we have some trimmers, like of course this guy here, and the one on the back here. And actually, is that all? Let's see. Yeah, as a matter of fact, that's it. There's just 2 trimmers per channel. I don't know what they do. Eventually I'm going to have to figure it out, but presumably we'd have some sort of scaling, at least. Maybe one of them is scaling, and the other is, I don't know, offset. I don't know, but eventually I'll have to figure it out. Just notice some of these capacitors are not JUCO. They are FCON, which is presumably equally suspicious. Yeah, not so good about that, but again, it's working okay for now. Eventually I'm going to have to replace them. But that would probably also mean figuring out what the calibration does, because it would probably throw it out of whack. Okay, so now we're going to try to do the repair. And I will admit, I've already done some thinking about this. I've tried a couple things. What I figured out is that it's quite difficult to actually remove the front to say, get in there and mess with the rotary switches. What I have noticed is that each rotary switch has a single common terminal, and then some terminals surrounding it that are used to actually select the range, and so it's not like a double rotary switch like I thought it would be. So what I think it may be pointing to is not the switch, or at least not the rotary switch. So what we're going to do now, I've set it here, so we're on the 1 volt range. This is pushed in, so this means that channel 2 is going to be controlled by this one, which is what we want. So this will be the problem range, and that'll be this. And then what we're going to do is, you see, for each one of these, there's a ribbon cable coming in and going to this connector here. And what we're going to do is measure our voltages on this connector when it's turned on, and we're going to compare the two, because they should be identical. Because if this is selecting the range, it should select the same range for both. And if it is identical, then we'd be looking at possibly a faulty component, like I'm guessing one of these logic chips. But we'll just take it one step at a time. So first of all, I'll power it on here. We'll set our meter to volts DC. Now let's just look at the front. So the light's on and it's slowly equilibrating. Okay, so first of all, I think this should be our power supply. So that's 14.89 volts. This is ground. This terminal right here, the trace wraps around and goes along here, goes to the middle terminal of the regulator, so that's ground. I'm going to keep my negative probe on ground, and we'll just go along here. So this is, of course, this is about 15 volts. This we have 0.7, 0.5, 0.7, 14.9, 0.7, 0.5, 0.7, 14.9. So that's nicely symmetrical, it seems. Now we go over here. So here we have 14.9. This is 0.07. That's not correct. 14.9. That's not correct. 0.05. No. 14.9. Yes. Okay, so it is different. If we put the switch out, we should get the same here as we get on channel 1. This is, of course, channel 2 board. So let's go across again. 14.9, 0.5, 0.5, 0.5, 14.9. So that is correct. So this does mean that our problem is not with the logic here, it's with the see, look at this. Yeah, okay, it's over here. It's in one of these sections. I'm looking at this selector switch. I'm also looking at the ribbon cables, perhaps. So let me think about it a little more, and then we'll continue from here. We're gonna do one more measurement here before we continue. Actually, I'm gonna set buttons pushed in. I'm gonna set this to the 0.3 volt range, which we know works properly. And what I'm guessing, here's my prediction. We're gonna get logic high, so for about 15 volts. So I'm gonna guess high, low, and that's ground. So this is gonna be high, low, high, low. There you go, and this is of course just power. Okay, so now we're doing a test here. I have the LW1641 function generator. We're putting in about 4 kilohertz. Doesn't really matter, but as you can see, we're getting about 1 and 3 there. And so what we're going to do now is we're going to try to, first of all, we're going to see if messing with the selector, if we can actually make it, okay, let's see, let's just turn this all the way up here. So now this should go to 0 if it's selecting like that. So as you can see, it kind of does that, but it does go to 0. Now if we carefully put it in here, you can see that no matter how much we exercise this, we're either getting the 0.3 range, or we're getting this range that we selected, the 100 volt range. So we're pretty confident that it's not the channel 2 selector, unfortunately. So now if we do this, we can also see that that it's not like it's a bad connection here. So this has essentially eliminated the switches, which is interesting. So that leaves the ribbon cables and the boards. Okay, so I reseated the ribbon cables, and as you can see, we're still having the same. What? Holy crap, look at that. Somehow it was there when we started, and then disappeared. That is bizarre. Okay, we gotta let's just try poking around a bit. See if we can get it to reappear. There we go. Look at that. Okay, I'm just pushing on the back of this circuit board. Now guess what this suggests? This suggests a bad bit of soldering. So what I'm going to do now, this here is the board that I was pushing on. So what I'm going to do, I'm just going to go in with my iron. There's enough room, and I'm going to go ahead and reflow those joints. And then we'll try it again. Okay, so it was a bit too difficult to do it just putting the soldering iron in from the side, so I have disassembled it further. And as you can see, there's the board there, and I've already done the resoldering. So hopefully it's good. We're going to test it out. We're also going to attend to something I just noticed. If you look up here, this is the place where the ground of this board is connected to the chassis here, and if you notice, that's pretty darn corroded, and it's corroded on both of them. So I'm gonna just go ahead and clean that up before I put it back together. Okay, time to try it. Oops, there we go. Okay, turn up the amplitude on there, and oh boy. Oh yeah, okay. Set this in. Okay, now let's mess with the board a bit to check that it's not going to manifest again. Great. I'll check the other ranges, but I think that we have it fixed. As you can see, I hate it when it does that, but as you can see, we're pretty much getting the same thing for both ranges here. Yep. And yeah,